particle moves in a straight line so that at time t seconds, its acceleration is given by this expression here. Given that the initial velocity is 20 meters per second, and that the particle is initially 30 meters to the left of the origin, find the distance traveled by the particle in the first 6 seconds of motion. So we don't know exactly how this thing moves. So we might want to investigate that to start with. So let's look at the velocity, which is the integral of the acceleration. So that's going to be 6t squared over 2 minus 19t plus some constant. Now we know the initial velocity is 20. So that means that v is equal to 20 when t equals 0. And that means that c1 is 20 in this case. So I've got that v is equal to 3t squared minus 19t plus 20. Now if I want to work out the distance that this thing travels, I'm going to be interested in when the velocity is 0, because when it's 0, it might change direction. So 3t squared, take away 19t plus 20 is equal to 0. Can I factorize this? So if I have 3t and t, 5 and 4, and make them both negative, that works. And so I'm going to get that t is equal to 4/3 and t equals 5 when v equals 0. Now this is important, and we'll come back to this later, so I'm just putting a box around that to highlight it. Now if we go for the displacement, which we know is the integral of the velocity, that's going to be 3t cubed over 3, take away 19t squared over 2, plus 20t plus c2. Now we know that s is equal to negative 30 because it's to the left of the origin when t equals 0, which means that c2 is equal to negative 30. So s is going to be t cubed minus 19t squared over 2 plus 20t take away 30. Now to work out the distance travelled, I'm going to need to know the displacement initially, and we do know that because we were given that in the question. I'm going to need where it is on each occasion that it's stationary, and I'm also going to need to know where it is when t equals 6. So s of 0 is nice and easy. That's going to be negative 30. I'm going to need s of 4/3. I'm going to need s of 5. And I'm going to need s of 6. So I'm going to put in 4/3, and I'm just simply going to put equals, and then it's my last answer. And then I'm going to do answer cubed, take away 19 over 2 times answer squared plus 20 times answer, take 30. And that gives me negative 482 over 27. And just as a matter of interest, that's about negative 18. Now I need S of 5, so that's going to be 5 cubed, take away 19 over 2 times 5 squared, add 20 times 5, take away 30, that gives me negative 85 over 2, and that's negative 42.5. And then S of 6, which is going to be 6 cubed, take away 19 over 2 times 6 squared, add 20 times 6, take 30, which is negative 36. Now the picture that I've built up here is of a particle that starts at negative 30, and then it's going to travel this way for a bit. Correction, this was negative 19-ish. So it starts at negative 30 and it's going to travel this way for a bit. It's then going to travel back that way, and then it's going to come back a bit. So to get the total distance, we need to consider all of those. So how far did it travel here? So in the first part of the journey, that's negative 482 over 27, take away negative 30. Then we need the middle part of the journey, where it travels from here to here. So that's negative 482 over 27, take away negative 85 on 2. And then finally it goes from here to here. So that is negative 36, take away negative 85 on 2. And all I've done is arrange these so that they all end up positive, because remember, distance is always positive, not negative like displacement can be. So I have negative 482 over 27, essentially add 30. So that's 12.148. So that one is 328 over 27. And then for the next one, I'll just go and edit. So let's delete that. And we'll take away negative 85 on 2. And that gives me 1331 on 54. And then finally, we have negative 36. Add 85 on 2, which is 13 on 2. And that will give us the distance covered. So we've got 328 on on 27, add 1331, well, that is a fraction really, 1331 on 54, add 13 on 2, and that gives me 1169 on 27 meters, which is approximately 43.3.